I think we're live.
All right. Hello, one and all. I'm Pratik Kannadi. I'm a security architect for IBM Cloud. Today, I'm joined by my business partner, Anand. Anand, you want to introduce yourself?
Hello, everyone. My name is Anand Kashyap. I'm co-founder and CTO of Fortanix. We have been working with Pratik and IBM Cloud for the last few years to bring confidential computing to IBM Cloud, and we're very excited to talk about it today.
Yeah, thank you, Anand. So yeah, that's the context for this call. All right. I think today Anand and I are going to share some of our work in the process, talk about what we learned over the last 3 years now, and we'll share our optimism around the opportunities around confidential computing in the near term. So with that, I will go to the next slide. So this journey started about sometime in 2017. Back in the day, we on IBM side, we were working on KMS for envelope encryption or data at rest encryption, and we're working on PKI, or certificate management. So the question became apparent: is the data protection complete? The answer is no, right? And then what can we do about it, right? So we told ourselves a few years back that the data protection is incomplete without protecting the data in use, right? So so that became our mission statement, right? We said, okay, let's go and chase this genre and bridge the gap in data protection by providing a solution that encrypts the data in use and complements other solutions in the space of PKI or certificate management, to be precise, and KMS. So once we have this understanding, right? So so we also understood very early on, right? I think protecting data is one thing, or security by and large is one thing, but giving the assurance to the end users, especially to the users we are trying to cater this offering, was another. So that's where we understood we have to also give the assurance, a technical assurance, as opposed to operational assurance to the adopters. Meaning we want to be in a position where we can say, I cannot access your data, as opposed to I will not access your data, right? So in the next few slides, we'll talk about this and the data in use protection itself in the context of a technology and what we have done through that. So yeah, so our mission statement has been to sort of deliver a solution that protects data in use, and also give the users the assurance they need to trust that the workloads are being protected in memory, and nobody has access to this workload, even an administrator who typically has access to a given box. So with that, we explored the available technologies in the industry, right? So back in 2017, very early on, we understood Intel SGX can be a viable path for us to explore, right? So when we talked to some customers in the early days, right, we understood that technology is great, so is the frictionless user experience, right? So there is this technology called Intel SGX that enables you to protect your workloads or data in memory. However, the path to adopt this technology seemed quite bumpy for some, right? So that became our mission statement. So we said, okay, we want to deliver a solution, preferably a deployment time solution, as opposed to a development time solution, because we understood the people who wants to consume the offering, or people who want to adopt secure enclaves, right? We want them to focus on the core competence, which is developing applications, and we want to take the overhead to the deployment time and build a solution that is cloud native and aligns with the DevOps strategy and helps users to adopt secure enclaves, in this case, Intel SGX. So that's where we introduced ourselves to Fortanix, and we started collaborating, and I will let Anand talk more about that aspect in a couple of slides from here, and how Fortanix is helping us deliver on that mission. So our product, Data Shield, right? So what it is. So this is how I put it. Data Shield is an enabler or deployment time tool that helps you adopt secure enclaves, or to be precise, Intel SGX or software guard extensions. Right, so in doing so, we want a no-code change user experience, meaning a typical DevOps flow, right? If you go from left to right, so you write your code, you commit your code, you test your code in your pipelines, you build your image. That's where we want to integrate in your typical workflow and take your image and convert that image into a secure enclave counterpart. So we want to do that seamlessly at scale. So that's what we do. So we promise you that, for the runtimes we support, you can trust us to do the conversion without any code changes in your application. So, and also at the same time, we understood that we want to align with our larger container-first strategy. So we were focused on containers. So today, Data Shield is available on both flavors of Kubernetes on IBM Cloud, both IKS and Red Hat OpenShift on IBM Cloud. So we also support runtimes beyond what Intel SGX natively supports, right? So we support Java, Python. Also, we publish some pre-canned images, so you can try the core value of Data Shield with a couple clicks. So we publish images for HashiCorp Vault and MariaDB and Nginx. So you can try Data Shield by deploying these pre-canned images on your cluster. So before we go to the next slide, on the bottom, you can see the typical journey we present to the users, right? So idea is that you already have a cluster, right? So you provision a cluster if you don't have one. This cluster, it can be IKS or OpenShift cluster on IBM Cloud. So you create a cluster with the right worker nodes. When I say right, I mean a worker node that has SGX enabled in, right? So once you have the cluster, Data Shield, the offering is, think of it as a help chart. So it's a software. So back in the day, you buy software, install on your infrastructure, similar pattern. In this case, the infrastructure is Kubernetes, and the software is Data Shield. So when you install that Helm chart on your cluster, you get your own single tenant offering or software that runs on your cluster within your trust boundary and within your data plane. So there is no outbound dependencies. Everything is contained and runs on the data plane that you own and manage, right? So, and it has a UI and an API. So the API is the one that integrates with your DevOps pipelines and does the conversion of your applications into secure enclave counterparts. So far, this has been our journey, right? So we started with the infrastructure on the left, right? We delivered today on IBM Cloud. You can provision Intel SGX servers from your account, and you can also provision a Kubernetes cluster with worker nodes that are SGX enabled. And you can install Data Shield on this cluster to get your own single tenant offering that runs natively on your cluster and helps you build and manage secure enclaves on your cluster with full authority and ownership of your workloads. So here, I want to pass the ball over to Anand to sort of introduce himself again, and also and the work we have done over the last several years, and show us how Fortanix, or precisely their Enclave OS, is enabling Data Shield achieve this mission. Anand?
Thanks, Pratik. Yeah, so let me give you some background about Fortanix, how we started, and how we found a natural partner in IBM Cloud, and the vision that Pratik and team had for confidential computing and securing data in use. So Fortanix was started about 5 years ago in 2016. We are based in the Silicon Valley in California, and our mission as a company is to solve the problem of security and privacy that exists as more and more workload and compute is moving to the cloud. Ambuj is our CEO, and I am one of the co-founders. And in the past 5 years, we have seen tremendous growth. We have raised 2 rounds of funding. The most recent round was a Series B round led by Intel Capital, and then other VCs in the Valley, like Foundation Capital and New Tribe as well. Now we have more than 100 employees in the company. We have, and we are very fortunate to have partnerships with some of the large companies in the enterprise space who are taking encryption and security to the next level, such as Intel, VMware, and IBM Cloud, of course. We also partner with all the major cloud providers to provide secure and confidential computing in the public cloud. In particular, what we have been doing since the beginning is we pioneered this new field, new technology called runtime encryption, and it is now being called confidential computing. The idea is you take hardware security features built into the hardware, such as the CPU, and use that to secure your workload, secure your data and applications running in an infrastructure where you don't control the infrastructure. So it can give you privacy for your data as well as code running in the public cloud. It has been recognized as confidential computing more recently, and we are one of the founding members for the Confidential Computing Consortium and very active in that consortium as well. So what do we do then? So there are two components of the solution that we provide. There is a confidential computing manager, which is responsible for orchestrating and managing the secure enclaves that you create. Because once you've created the enclaves, you still need to be able to make sure that they're running with the right permissions. They are actually enclaves and they're not a fake application pretending to be an enclave. You need to make sure that the enclave is running on a genuine Intel SGX-based hardware, and it's running with the latest microcode updates and latest security patches. So Confidential Computing Manager, and I'll talk more about it in a bit, it provides attestation and various such capabilities around orchestration for enclaves. But then the other part is how do you build these enclaves? So there are various ways available in the industry, in the market, by which you can build secure enclaves. What we have done is we have provided Enclave OS, which is essentially a user-level library operating system, which makes it very easy to take an existing application and without having to modify the application, without having to change the source code, without having to recompile the application, we can just take that application and wrap it with Enclave OS and run it in a secure Enclave technology. We make it even easier if your application is already bundled as a container. So if you have a container image, we provide a conversion service where we can take the container image, we depackage it. When we depackage it, we separate the application and the libraries that are required to run the application and the binary, and then the configuration. And then we add two things to that application image. We add Enclave OS, which is our library operating system, which is essentially an implementation of the Linux system call layer, such that all the system calls are implemented to run inside a secure enclave. And then the second thing we do is we change the configuration so that the entry point for the container becomes our application, which is responsible for creating the enclave and then loading the original application and the libraries inside the enclave, measuring it to make sure that we are loading the right application. And then we repackage all of this into another container image. So let's say you started with a container image for an application like Nginx, and with some configuration. What we'll do is we'll take it apart, put Enclave OS, change the entry point, repackage it, and now your new image, let's call it Nginx-SGX, will be created. And that can be pushed back into your Docker registry that you might be getting from the cloud. And then you can orchestrate and run this application just like you would have run your original application image. So you can use Kubernetes or OpenShift to launch your application and manage it. Next slide. Yeah, so what we have done with Confidential Computing Manager is the first thing I just explained. We make it very easy to take an application, convert it to run inside SGX, and give it the security. So once you have done that, you get all the benefits you get from running an application inside secure enclaves. You get confidentiality, so nobody can look into the memory space of what your application is doing. So you get in-memory protection. You get integrity protection. So this by using Intel SGX, you also make sure that if somebody goes and changes the application, now it's a new version of the application, you cannot go and decrypt secrets or other data that you might have encrypted with the original version of the application. So you get integrity protection. The third thing you get is isolation. So every application runs inside its own enclave. And even if somebody has root permission on the host where the enclave is running, they can't peek into what's going on inside the application. So that is very powerful. So the base thing is you can bring your application, convert it, run it inside secure enclaves. That is great. But we go above and beyond. So what we can also do is we can also take multiple components of an application. So most modern applications in the cloud today are not run as monolithic applications. They are run as microservices. Even a simple web service typically gets deployed as 3 different components. There'll be a front end. It could be something like an Nginx-based front end. There would be an application logic that might be written in Python or some other web-friendly language. And then there would be a database where you would actually store the data that is created by the application and read by the application. What we can do is, typically when somebody is running these applications in the cloud, they will run them in containers. They will scale each component independent of each other. Maybe you need more front-end replicas, you can do that. Maybe you need more backend or more databases, you could do that. What Fortanix can do with Enclave OS and running on IBM Cloud, for example, is we can take each of these components, make them compatible with secure enclaves, run them inside SGX, and then we provide the management interface, which is Confidential Computing Manager. It is also called Enclave Manager in some places. So Enclave Manager or Confidential Computing Manager can verify the authenticity of the applications that are running in these containers. And it can check for remote attestation by going and checking it with the Intel attestation service. And after verifying that it's the right application running on the right hardware that has been approved, it can issue a certificate that the application can then use. Once the certificate has been issued, now if connecting to the web service, they don't need to go and again verify whether the application has the right Intel SGX specific attributes, and they don't need to go and verify Intel SGX attestation. They can rely that on Enclave Manager to have done the verification and issued the certificate. And as long as you can verify that the certificate is issued by Enclave Manager, you can trust that the application is the right application that you can trust and it's running on the right hardware. And that is between user and the application. But even within this ecosystem of various components which form the application, you can also use certificates and use mutual TLS to establish trust between the various components of this application, which has multiple parts to it.
Well, I think to complement Anand's point, that is very powerful, right? So up until now, even in the context of MTLS, you would have used certificates even in the best case, distributed upon domain validation and such. But now here you're using MTLS with a root of trust tied to the silicon, because that's where GX is, right? So I think that's a very powerful use case there, Anand.
Yeah, thanks, Pratik. And we go even beyond that. So once you have created an application, now you have various components of the application that run inside SGX. Now what you can also do is you can enable use cases, or you can build solutions. So if you go back to the previous slide, Pratik. So if you look at the last picture I have here, what you can do now is you can enable use cases such as privacy-preserving analytics. And examples of this is if there's data coming from different sources, let's say from different banks or some telecom business and some financial services industry, which are not allowed to share data with each other. What you can do is you can bring all that data inside the secure enclave that you have created using Enclave OS, and that you can manage using Enclave Manager. And then you can enable useful business insights. You can run analytics on the private data by decrypting the data only inside the secure enclave. And this is being used for anti-money laundering and fraud protection.
So I know we have a use case to dig deeper into that. So is it fair in saying, if I have a data shield cluster running and I have the business logic where I'm trying to pull data from different sources or the owners of the data, now I can do that. I can convert this business logic into an enclave counterpart. That's step number one. And the certificates that we issue will give them the assurance that this piece of business logic is protected in memory. And at that point, they can share data into the enclave over TLS as an example, and collaborate and generate value together.
Absolutely. And this is going to enable use cases that were not even possible previously. The data is that we're talking about, financial data, PII data, healthcare data, they're regulated by law in many cases. So you can't really take data and bring it together from different sources. But with secure enclaves, and we have seen regulation changes as well, and we'll talk more about that, which allow data to be brought in inside secure enclaves. And you can bring encrypted data. You can combine it with a robust key management service, which can verify that the keys can only be given to the application after verifying that it is running inside the enclave on the right hardware. And by combining remote attestation, combining the IntelliSGX's encryption and data in use protection, you can build solutions where the use cases around multi-party or privacy-preserving analytics now become possible.
Well, I think a good analogy that comes to my mind is, we are giving them a brand new set of brakes. Yes, you can think of them as something that slows you down, but at the same time, that gives you the confidence to drive faster. That's what is happening here. Yes, it protects your data in use, but now you have this freedom to build new business models, like you said, to the right here, Anand. So they can generate value, which they cannot before this. That's great.
And
yes.
I'll provide some more color on the Confidential Computing Manager as well. So Confidential Computing Manager, so think of the whole solution space in terms of having a control plane and a data plane. So the data plane is where you have your enclaves, you're running those enclaves, you're getting data in use protection, all that is great. But then on the control plane, which is a Confidential Computing Manager, you get various other advantages of having that control plane. So you can get remote attestation, you can create policies such as which application is allowed to run on which Kubernetes cluster. You may want to have a test cluster and a dev cluster maybe at some point of time. Or some applications could only run test, some could only run on dev. Or might want to do geofencing, for example. So doing those kind of things in terms of policies and having strong cryptographic enforcement of those policies becomes possible by using Confidential Computing Manager. You also embed a CA inside Confidential Computing Manager. So we make it very easy for end users and other applications to verify the remote attestation capabilities that the IntelliSGX enclaves provide. What we do is by verifying the attestation, after that we can issue a certificate. And every application and browsers know how to verify certificate, but verifying attestation reports is hard. So by exchanging the attestation with a regular TLS certificate, we make it very easy for end users and clients to consume confidential computing. Confidential Computing Manager can be used to manage enclaves running in various places. What we're seeing is people are taking applications, running them in confidential computing environments in the cloud. In IBM Cloud, you can run it on Data Shield, on IBM Kubernetes Service, but there are some customers who want to run it on-prem or in hybrid environments or in remote places. Now, the new thing that's coming from IBM, and Pratik can talk more about, is satellite. It should be possible to run confidential computing in satellite as well. And having Confidential Computing Manager being able to connect and whitelist and enroll those nodes, regardless of where they are in the cloud or in a satellite environment, and being able to provision applications on top of that and enable policies, that is pretty powerful.
Yeah, I think, you get, to reiterate Anand's point, I think, like I said earlier, I think you can get Data Shield. It's a software that literally runs on your data plane, on your cluster, installing takes about a minute, and conversion of your applications to secure enclave counterpart takes about 20 seconds. So you can literally go from your status quo to running your workloads in secure enclaves in less than 10 minutes. So I think that has always been our goal, creating the frictionless user experience. And with Fortanix partnership here, I think working with Anand and team, we were able to do just that. So Anand, if I can go to the next slide. So before I delve into this use case that we built, which is in production, right? I want to touch upon what's happening in the industry, right? At least since GDPR, right? So GDPR by and large said who is who, and that's like you are the owner, controller, processor, and then what you can or cannot do. But which is great progress, but the business still wants to use data to generate value, right? So the question was just that: how can you, in this case, there is this new regulatory control that went live in Germany that is asking all the insurance providers, right, to encrypt the patient records in memory, right? This control went live on January 1st of this year, and the platform and our adopter built on Data Shield went live, which is in production as we speak. So I think one thing we did with collaboration with this adopter is that they were able to focus on writing or building the platform itself, and they offloaded all of the secure enclave counterparts or secure enclave parts of their platform to Data Shield. So they were able to meet this aggressive timeline, right, and go live as planned on 1st of this year. And Data Shield really helped them achieve that goal and help them save the time, right, and help them not build a team around a certain TEE or trust execution technology or execution environment technology. They were just focused on what they do best, which is developing the platform, right? So that is the real value here. So going back to my point on change in regulatory landscape, right, this is a good example, right? So even with the controls that we have in place, we can still develop privacy-preserving platforms and deliver value to the end user, right? So that is a theme here. So with that, I will let Anand chime in and share some of his observations as well in this space. Anand?
Yeah, so if I can describe the user flow for what has been enabled with this use case. So what happens is the healthcare records of every user, and users are citizens of the country, so which means there are tens of millions of such users. So what they do is the health records for each of these users are kept encrypted at rest inside some centralized databases, and then the users hold the encryption keys to the data that is encrypted in the databases, and the encryption keys could be held in their phones, for example. And when somebody has to retrieve the data from the database, then the encrypted data is brought in, and it can only be processed inside an enclave. And then once data has been loaded inside the enclave, the user can verify it's the right enclave, it's running on the right infrastructure, and then provide the encryption key over a secure channel, at which time the data can be decrypted and processed. So this provides a very strong and secure mechanism by which data is protected at all times, kept encrypted wherever necessary, and it gets decrypted only inside secure enclaves, and the keys are held with the users and not in some place where it can be abused. So building that on top of Data Shield gave a lot of advantages. One was the speed of how soon this could be brought to production, because it was easy for the team to build those applications that were going to run in this environment and provide the use case. But being able to very easily take that application without having to rewrite, without having to modify, run them inside secure enclaves, and get the assurance of the enclave manager and attestation, that is very powerful. And then this also has to be very scalable. So being able to run it on top of a Kubernetes cluster where you can run several enclaves on a single machine, and then be able to scale with demand as more users, more customers are brought on the platform. This gives them a very easy solution to be able to do that.
Yeah, to complement Anand's point, think of it this way, right? I think with this platform, if the platform is live already, so every time a user logs in, we need to create a enclave dynamically on the fly and load that encrypted data into the enclave and decrypt it and show and run insights on it and show that report to the patient or to his or her physician. Right, all of that is happening in real time, and all of that is happening at scale, right? So I think certainly the fact that we built this on Kubernetes helps, right? Because as the cluster scales, the worker nodes were added dynamically, and the number of enclaves scales laterally. But I want to bring this up because it works really well for microservices, right? I think in spite of I think one might argue of the enclave size on SGX. Actually, this current generation of SGX is really tailored really well for microservices, and this use case that we built, which is in production, is a testament to that. Anand, do you want to add anything there?
No, I'm good. Did you also want to talk about the?
Yeah. So right. So another thing we saw after EHR, which is e-health record, is there's a new control that came in Germany, which is asking for similar rigor in the pharmacy space, which they're calling e-receipt or e-prescription, right? So now they want to do exactly that, but for a pharmacy side of the business. So I think that these use cases in Germany and probably, hopefully, more in the EU at large, I think shows what Anand and I were saying earlier, right? I think it's at the core, it's a security story, but it is at the same time, it is also a AI story or analytics story or any of these data-centric solutions story, right? With that, I will go to the next slide, Anand. You want to take a, yeah.
Sure, and I'll just add to that, Prateek, that yeah, while it's all about security and analytics, what's also important is how to make it work in production and how to make it work at scale and how to make it very seamless for the developers. Because security often comes in the way of usability and it becomes very hard to implement secure solutions. So being able to provide a very easy onboarding, easy conversion of applications to SGX-enabled applications and tying it with Kubernetes and modern microservice architecture, that makes it very easy to bring these kind of real-world applications and take them to production very quickly. Related to the previous use case, and this in a different space though, is another use case that we're seeing quite a bit from the financial industry, and this is around doing anti-money laundering or fraud detection. And typically how people are trying to do that is using a concept called federated learning. And the difference between federated learning and a more traditional machine learning would be that instead of bringing all the data to a central place where you do learning on top of that, in federated learning, the data never leaves its environment. So if you're trying to do anti-money laundering, which means multiple banks in different sovereign nations need to be able to exchange some information with each other and try to figure out whether there is somebody who's doing anti-money laundering. Now, getting them, all these banks, to be able to share data with each other is very hard. But with federated learning, what can be done is you can create a model, a machine learning model, and then you can run these learning algorithms with the data in different places. So you can push the algorithm to the data instead of bringing the data to the algorithm. And then you can learn from various places and then come back to some central place where you can take the average of all the coefficients in your model, and then you can readjust your central model. And then you can push out the central model to all the edge places. And then you can keep doing it so that you can keep improving the model. Now, all that is great. Data didn't have to leave its location from the bank, but still, there's still some concern around how do you make sure that the model you are getting from the central place, how do you trust that model? Uh, and when that model is being sent to the central place, how do you make sure that the central place where there's a cloud or compute farm where the models are being averaged out or the coefficients are being averaged out, how do you make sure that that can be trusted? Because one bad player in this ecosystem can start corrupting the model, both the central model and the model that everybody else is seeing. So being able to protect against this kind of abuse is something people are looking for solutions for. And what we have going on with a number of concepts right now is running these models also inside secure enclaves. So when the model gets pushed out to different banks or different entities who are participating in this federated learning, the model, the learning, all the algorithm, they will all run inside secure enclaves. And then the central entity, which is responsible for taking averages, for example, that also runs inside secure enclave. And then with combining it with enclave manager and combining it with key management service, for example, Fortanix has a key management service called self-defending KMS built on top of confidential computing. You can assure that as the models are being exchanged, as the algorithm is being run, they are all protected. The models are encrypted when they're being exchanged between different entities. And then the algorithms, the application running the algorithms run inside enclaves and they can be trusted by different parties. And that creates a more bounded and foolproof solution for this problem of anti-money laundering.
Yeah, I think to complement your point on, as we're working on enabling data shield on satellite, and the folks in the audience who are familiar with satellite, I think is it safe to say if you can one bank to can be two satellite locations and data shield is installed and running there, so they can do the federated learning there in this distributed environment and generate value and around these data sets that never leave the perimeters of bank one and bank two.
Yeah, absolutely. I think running the models on satellites and then bringing it together on a central instance in IBM Cloud, I think that will be a great model where, again, data never had to move, but then you also assure the integrity and confidentiality of the models that are being exchanged.
Right. This also reminds me, Anand, about, I think, the opposite of what you're saying, federated learning, the AI itself, or machine learning. If you remember, about 2 or 3 years back, one of the first use cases we developed with folks from MIT Media Lab in the healthcare, right? How different healthcares can come together to or share the data to like a pharma company who can use this data to make better drugs, as an example.
Yeah, absolutely. We are seeing a lot of use cases in healthcare. One of the projects we have is with a healthcare provider in California. We're working with the university as well at UCSF to do research on healthcare data. And that is absolutely what you said, where data is being brought from different sources. And these are very sensitive healthcare data. But then to generate healthcare AI algorithms, you need to be able to validate your algorithm on various diverse data sets. So you can't just say, I've tested on the data set from one hospital and that's good enough, right? You need to get data from different countries around the world, from different demographics, different races, and being able to get all that data and process it, that becomes very powerful.
Right, to make unbiased decisions. Yeah. I think with that, going to the next slide, Anand. So I want to just summarize on different industry verticals and the use cases that we have seen so far. Right. So in the banking and payment section, we have seen how crypto wallets can use data shield to protect, your in this case your currency. Right. And similarly, we have seen in the energy space as well. In the healthcare, we talked about it. And the blockchain, as you know, irrespective of what the blockchain is, the trust story distills down to the signing key and the signing code. So we have seen use cases in that space, how one can protect their the signing code and the signing keys using Data Shield or SGX. And we have seen use cases in the messaging space, how you can protect, how these applications are protecting the end user data while delivering value to them. So yeah, I think this is a very promising space, and what we have seen so far, I think, is only, I truly believe, is only a tip of the iceberg. So I think that's what makes it truly exciting. Before I go to the questions or anything, Anand, do you have any final remarks to conclude this session here?
I just say that confidential computing has been in the works for the last few years, and now with the use cases we talked about, it's evident that now it's ready for prime time. It's now being used in production. Right. It's securing workload, securing data, very sensitive data out in the field.
Right. So, I think a good example that comes to my mind, Anand, to the point is, I remember vividly about 3 years back, I was doing internal presentation in IBM, and I remember the audience that showed up and the questions they asked. And I did the same session a couple of months back. It's like an audience were like tenfold in attendance. Also, the questions were no longer about what is confidential computing, right, and how it can protect me. They actually know what it is, and they already want to use it. They're bringing the use cases and asking me, hey, this is a use case I have. Tell me, how can I use Data Shield to protect this? So I think that kind of explains the progress we as a community have made over the last 3 years. So again, before we go to the questions, a quick thanks to everyone and also to Anand. And the next time you see Anand and I, we will probably show you how Data Shield can be installed in your satellite environment, on the edge, or in typical multi-cloud environment. So we'll hopefully meet you all again. So with that, I will stop my screen sharing here, and I will see if there are any questions here.
I think the first question is, what industries do you see benefiting most in the immediate term from this innovation? Maybe I can address
Sure.
what I'm seeing, and then you can add to that.
Yeah.
So in our experience, we're seeing a few industries which are taking to confidential computing very quickly. The first one is healthcare, and healthcare, because healthcare data is generally very sensitive. It's protected by regulation, and we're seeing companies trying to do analytics on healthcare, or trying to build electronic medical records or health records in confidential computing environments. So that's one. The second one is financial industry. Again, when you're exchanging data from different places, in financial industry, a lot of PII data is collected. So how do you protect that? The third one I'll add is government. So you're also seeing a lot of demand in securing data in the government sector.
Yeah, I think that's pretty much my observation as well, Anand. I think healthcare has been, we built use cases together that are in production, obviously. I think same goes for financial sector. I think, would you mind explaining more on some of the challenges that users are seeing in the financial sector or in the government space, right? How does the typical conversation go? What are the concerns they are seeing? Are they more data security concerns, or at the same time, it goes hand in hand with the compliance as well, right? So can you speak to that?
Yeah, so companies are looking for both security and compliance. So with some of the recent privacy regulations in Europe, we have GDPR. Here in the US, we have CCPA in California. And then there are other data sovereignty related regulations everywhere in the world. There are a lot of banks and companies which have to comply with these regulations, and they need to build solutions to be able to do that, right? So confidential computing is a great way to be able to address that. The other thing we are seeing in the financial world is the ability to do certain use cases like money laundering or fraud, which require collaboration or getting data together from multiple sources. So those are the opportunities. In terms of challenges, I think confidential computing is new, so a lot of people are still learning about it. They're still trying to find out, where to go, what platform to use, which public cloud to use. Most of the banks are moving to the cloud now, and everybody is in various different stages of their cloud migration journey. And that is another, I would say, reason why people are looking at technologies like confidential computing, because as long as you had everything on-prem, you had your data centers, you had your guns and guards to protect your data. Now, when you move to the public cloud, you don't have that, and then now you have to keep your data encrypted, and you can't just rely on your public cloud to encrypt your data and also hold on to your encryption keys. So how do you move your data, keep control of your encryption keys, keep control of even the data when it is being used in the cloud? That's where confidential computing is very powerful.
Yeah, like, and also like Gartner said or showed, right, where this genre of compute is in the hype cycle or in the so-called innovation S-curve. I think that only speaks volumes to the tremendous amount of innovation that is yet to come in the next 2 to 5 years. I think it's truly an exciting space to be. So I think, Anand, we are 45 minutes into this session. Maybe if there are no other questions, it is the right time to wrap up. And hopefully we'll find our way here and talk to the audience again. Any closing remarks, Anand?
I'll just reiterate that confidential computing is now available, real, and in production. So I encourage people to start looking at how they can use confidential computing to secure their workload in the use.
Yeah, definitely. I think, if you can literally try the real value of confidential computing literally under 10 minutes on IBM Cloud using Data Shield. So I encourage you all to start your journey on Data Shield's documentation. We have a beautiful getting started page there that tells you how you can onboard yourself. It will also tell you how you can take a typical application and convert it and deploy it and secure your application. There are demos there. So I hope you all will give it a try and bring us some questions. Thank you, Anand. Thanks for joining.
Thanks, Prateek.
Yeah, thank you all.